When reviewing linear inequalities, we want to start by reviewing some of the symbols. So I can say that 3 is less than 7 because the mouth opens towards the larger number. And I can say 7 is larger than 3. Again, the mouth opens towards the larger number. If I want to review graphing inequalities, and I say x is greater than 7, what I mean is on my number line at 7, I want an open circle to represent that we're not including 7 itself, and all values larger than 7. So values like 8, 9, 10, 10.2, all the values in between, infinite values larger than 7. If I want to represent x as less than 7, again, I'm going to put an open circle on 7, and all values less than that need to be included. So 6, 5, and so on, and all the values in between. So again, infinite values there, not including 7, all values below. X less than or equal to 7 means I'm going to put a closed dot on 7 to include it, and I want all values again less than 7. So it looks very similar to the example above, but we are including 7 as well. If I say x is less than -5 or x is greater than 5, I'm talking about the extremes on the number line. So 0 is in the middle, -5, +5. I want all values larger than 5. So 6, 7, 8, 9, 10, these values up here. And I'm not including 5 itself. And values less than -5. So don't include -5 and the values beneath -5, like -6, -7, -8. So we're talking about values that are more than 5 units away from 0. If x is between -5 and 5, I like to call this the sandwich notation. What this means is that x is sandwiched between -5 and 5. So it's somewhere between -5 and 5 on the number line. So we want all the values between, and this time we want a closed dot to indicate that we're including -5 and 5. You'll also see an interval notation, something like this. X is between -5 and +5. So that's not a point, that's representing the interval between -5 and 5. -5 and 5 are at most 5 units away from 0 is the other way that we can say this. Okay, so once we understand that, we also have to look at what happens when we do different operations with inequalities, because they're not quite the same as an equal sign, almost the same, but not quite. So if we start with something like 3 is greater than 2, this is true. 3 is a larger number than 2. And we add a number to both sides. So let's say I add 1 to both sides. I can do this with an equation. Hopefully everyone agrees. And it would still be true. So let's see if it's true for an inequality as well. 3 plus 1 is 4, and 4 is still greater than 3. Same thing with subtraction. I could subtract from both sides, and it would still be true. If I multiply and divide, let's see what happens. So let's say I took 3 and multiplied it by 2, and I did 2 times 2. So I multiply both sides by 2. Is it still true that 6 is greater than 4? I think we would all agree that that's true. Let's look what happens though when we multiply by a negative number. So let's say instead of +2, we multiply both sides by -2. So now I would have -6 is greater than -4. Because we're talking about negative integers, this is no longer true. So all of the operations that we're used to with dealing with equations, where the left side is equal to the right side, are valid here as well. The only thing is that when you divide or multiply by a negative number, you have to switch the sign. So this is actually going to become a less than. So that's the only rule that you have to keep in mind when you're dealing with these things. Okay, so let's look at a linear inequality then. If I had something like -3x plus 1 is less than or equal to 10, I can treat the first step just like I would if I had an equation, because I know that I can subtract or add to both sides without changing the truth of the inequality. So I'm just going to subtract 1 from both sides. So I would get negative 3x equals 9. So I'm basically just taking a 1 away from both sides. Okay, and then the next step in isolating x would be to divide both sides by negative 3. With an equation, there's no danger with this, but we have to be a little bit careful. When we divide both sides by negative 3, we have x by itself, and over on the other side now we have negative 3. But we have to remember that when we're dividing by a negative number, we have to flip around that inequality. So x is actually going to be greater than or equal to negative 3.